We'll group as if it's our last. We are implementing the recently published paper about Linformer, a refined version of the transformer model. The traditional transformer is expensive in both time and space, while the linear transformer could reduce the complexity by projection.
As the linear transformer with n by np matrix uses an On squared time and space with respect to sequence length, whereas for linear transformers, since its self-attention is low rank, we could apply two additional linear projection matrix, EI and EF, to reproject the key and value matrix, so the size of P matrix is n by k. If n is much larger than k, this matrix computation will be linear. As you can see, the linear projection will be performed in the key and value matrix. Next.
The author also used parameter sharing as an additional efficient technique, which includes headwise sharing, key value sharing, and layer-wise sharing. Among all, the author suggests us to use layer-wise sharing to save time and memory.
And for the first experiment, we find that when the sequence increases length, the inference time speedup are even more dramatic. And this is because the self-attention matrix time complexity is On by k, and when n is larger than k, we can ignore that. So the time complexity will become linear. And for the second experiment, we find that when the k decreases, the perplexity is almost as same as the vanilla one. So we can conclude that the performance is good when the transformer becomes linear. And for the last experiment, when we just use a single projection matrix like the layer-wise sharing, the resulting perplexity is almost matches the non-shared model. So for the conclusion, the author proposed a new highly efficient self-attention mechanism which makes the transformer linear, and this approach is the big On with respect to the sequence length.